Hi grade 10s, unfortunately I'm not in our class today. You are going to be learning about arc length, so this is day 5 in the booklet and it starts on page 13. If you like, you can pause the video and have a go at the starter. I will post an answer on OneNote later on if you want to check that. Okay, hopefully you've had a go at that. That's reviewing what we were looking at yesterday. So today we're learning about arc length. And we're going to be using our formula guides for this. We don't have a formula for arc length in our formula guide, but what we do have on the same page you've been looking at underneath the formula for the trapezium and the triangle is this. It's about the circle. We're not talking about areas today. We'll come to that next lesson. What we're talking about is the circumference. So the circumference is the distance around the outside of our circle. And you can see here we have the formula that's given to us, which is one that you should be somewhat familiar with, or it should at least be something that you can seems a bit familiar from grade 7. So it's C equals 2 pi r. So C stands for circumference, and then we're doing 2 times pi times r, and r is the radius of our circle. So how does this link to arc length? Well, arc length is just talking about a section of the circumference, so not the whole way around. So how can we turn this formula into something that's helpful? Well, it would be pretty easy if instead of dealing with a whole circle, oops, it's a bit of a wobbly line, I was just dealing with half a circle. So I think we'd all be pretty confident that to find the arc length when it's half a circle, we'd take the regular formula, 2 pi r, but we'd want half of it. So we'd either times it by a half or divide it by 2. I'm going to times it by half. Equally, I think everyone would be pretty happy if instead of having half a circle, I had 90 degrees here, because I know 90 degrees is a quarter of a circle. Because then, well, instead of saying I want to do my circumference and just find a quarter of it, a half of it, I want a quarter of it. So once again, I'd divide by 4, or I'd multiply by a quarter to get a quarter of it, and that would find that gold section. And the reason for that is our circle obviously has 360 degrees in it, so all we need to think about is what fraction of it is, of the circle we have. So I think half circles and quarter circles, they're pretty easy. Let's look at an example that's a bit trickier. So I'm going to scan down to page 14. I'm looking at 2b. Please pause the video, find that page so you can work through the notes as well. So here we need to find the arc length of the circle. So I'm going to draw it on here. This is the bit we're after. Okay, so if I was finding the circumference of the whole circle, I would do 2 times pi times the radius. The radius is 8 meters. So that would be the circumference of the whole circle, but I don't have a whole circle. I have part of a circle. How much of a circle do I have? It's definitely more than a quarter. It's not as much as half. It's a bit more than a third. I don't think it's an easy, straightforward fraction. But what I know is there are 160 degrees in this sector that they've marked out. So I know that I've got 160 degrees of the whole circle, and we know that a whole circle is 360 degrees. So there we go, we've got 160 degrees of a full turn. So that's the fraction of my circle that I'm interested in. So what I've done is I've taken the circumference of the circle and I've said that I want 160 degrees out of 360 degrees of it. So the angle I've got divided by the total angles in our circle. Okay, so now I'll just grab my calculator and calculate this. 160 divided by 360 times 2 times pi times, I think r was 8. There we go. Okay, obviously we're using pi, so we get this lots of decimal places. I think I'm going to round this to 22.3. So I'll round it to one decimal place. 22.3. It's a length. It's the distance around part of the circle. So it's a length. I'll give it a unit of meters. That's what our radius is measured in. Okay, so this is kind of a fairly straightforward question in that we're taking a formula that's given and we're doing a bit to it. It's not completely straightforward, but we're doing something to it. I want to look at one more question that's a little bit more challenging that I would say would probably be something you'd find in the level 5-6 section of a test. And for that, we're going to move on to the next page. If you want to pause here and do some practice of this skill, by all means do. Pause the video, have a go at 2A, have a go at question 1. You could even go back to the table. And I think the first question and the third question are kind of more straightforward problems. The other two in this table are a bit more like the one I'm just about to go through. So if you want to practice that and come back to this, please do. Okay, for those of you that are ready, let's have a look at question 3A. So all of the questions on this page, this is page 15, are a little bit different. Certainly they're not as straightforward as the one before, but they all have the same idea. So we need to find the radius for the sector below. So we're not told the radius. Looking at the diagram, I can see that 18 degrees must be this angle here. So they've told me that. Oh, and look, in the question it says the arc length of the sector is 22.9. So I know this distance from A round to B is 22.9 meters. So let's think about what we know. We know if we were trying to find the circumference, I can just write C for circumference, can't I? We would be doing 2 times pi times r. Now I don't know r and I don't know the circumference, so it doesn't initially seem very helpful. But if I was finding the arc length, how much of the circle have I got? I've got 18 degrees of the circle. So I would be doing 18 degrees out of 360 times 2 times pi times r. Okay, I still don't know r. But one thing I do know that I haven't used yet is the arc length. So I can substitute that in where it says arc length in my equation. And I'll have 22.9 equals 18 over 360 times 2 times pi times r. Okay, this is looking better now because everything is a number except for r. So I just need to solve this for r. I don't mind how you solve this. You can do this algebraically, isolating r and using a calculator to find what that comes to. If you are not so comfortable with that, you can graph the left side and the right side and find where they intersect. I think I'm going to try and do this algebraically because I think it is useful to practice these skills. So I'm trying to get r on its own. I'm dividing by 360, so I'm going to multiply by 360. Okay, so that gets rid of my fraction. That's a good first step. Let's just quickly work out what that is. Okay, 8,244. Did I do the right thing there? 22.9, yes. 8,244 is equal to 18 times 2 times pi times r. And then I just have to divide by 18 times 2 times pi. And I'm running out of space here. So I'll do 8,244 divided by 2 times, divided by 18 times 2 times pi. And then I'd be left with r. And then I can calculate that. So I'm going to take that answer from before, 18 times 2 times pi. There we go. Let's round that to 72.9. R equals 72.9. Right, let's check. Does that seem somewhat sensible? Yeah, we're dealing with quite large a fairly large arc length. We've got quite a small angle. That could be correct. And I need to think about my units. It is a length, it's meters. All right, so it's the same idea, but you need a bit more confidence because the unknowns are not where we expect them to be. You need a bit more confidence with your algebra if you're going to approach this algebraically. Or of course, as I said before, you can use the function app for this. So I would, if I was doing that, I'd go back to this line here that I've just pointed the arrow to, and I'd say, oh, let's make one of these 22.9 and the other one 18 divided by 360 times 2 times pi times the thing I don't know, my unknown. And I would zoom out until I get my intersection. Okay, and the x value is 72.9. Folks, there are, obviously, if you've got this far, I think you've probably tried some of the questions on page 14. There's others in page 15 to try. 3b is very similar. Question 4, it's the same idea, you're just looking for a different unknown. Question 5 is quite nice, you're looking for perimeters of the shapes. I would argue it's possibly a bit easier than 3 and 4. And of course, if you're on OneNote, you can go to the Level 5 Plus classwork. Day 5 arc length has some other nice problems for you to look at. Good luck, I hope that goes well.